Okay, let's go. So Alex actually wrote me via Twitter and told me that he wanted every one of you to smoke the cloud pipe, and therefore here I am to try to deliver as best as I can. So welcome to the cloud and to the brave new world. I'll start a little bit in the past, and you might ask yourself, what do dinosaurs have to do with IT? I'll try to explain it a little bit. Around about 260 million years ago, there were dinosaurs living on planet Earth, and they were happily living there until one huge impact around about 66 million years ago killed mostly 3/4 of all the living beings on planet Earth. And today, I think there's another huge impact on the horizon that is trying not to kill us human beings, but maybe the system administrator who might not be prepared for the next big thing that is coming here, and that is the cloud. And I'll try to explain in the next 40 minutes how I and you as consultants or system administrators at customers can survive this impact. So, a few words about me. My name is Hinisha, I come from Germany. I'm mainly doing enterprise accounts, so biggest customer I was working for in project was about 300,000 users worldwide, and I want to give you some of the experiences I made with doing projects in enterprise environments, and what basically changed nearly half a year ago when I joined into a new project at a startup. And therefore I will talk a little bit about how they are doing projects, and at the end I will try to explain how we can take best of both worlds to improve how infrastructures are deployed for today or even in the future. So when I prepared for that session, I tried to find a few pictures I had taken in the past from me. I couldn't find really much, but this was one of my first infrastructure migrations I did. It was somewhere late in 2004, and there were a lot of different servers that needed to be managed. And maybe you see it in the middle. I made an infrastructure migration of nearly 150 servers, and we put complete racks into the elevator, which was nearly 50 years old. Somehow we survived that migration, but in that time it was really hard to manage all of those different systems. So system SMS was just about to being implemented in the infrastructure, and I was in that time responsible for a Citrix farm, and I deployed new servers via sysprep and changing RAID 1 disks from one server to another. So it was a weird, if I think back, it was really a weird time how infrastructure was built and managed. And there are a few things I can remember from that time that burned into my mind, and the most touching sentence I've never ever lost focus on was never touch a running system. So my boss actually told that to me because everything we built up and we got running in some sort, we never tried to touch again because something could potentially break. And even today, big infrastructures are built to last for a long amount of time, just to not be in the position to change too much because something could potentially break in the production environment. And maybe you also know the typical IT administrator. I've seen a lot of them in different projects, and also some of my colleagues when I worked at a governmental agency. They were just like, if a user called, so it was like nobody wanted to talk to users, and users were like, they sucked, and just wanted to administrate my own personal environment. And it was, if you maybe check the link down here, there are a lot of stories that are really from real life scenarios where administrators behaved not like they maybe should behave with a user. And if you have a look at the projects that I did in the past, and I'm sure pretty many or much enterprises still today use something like a waterfall model to implement new infrastructures. Maybe are you using such sort of methods for new projects? So it's basically you do a planning session which takes a few months just to be sure to minimize the risk of implementing a new infrastructure. And this leads to many different situations, like lack of communications in teams where people are not talking basically very much with each other. So how does a typical waterfall project look like in the past and even today? This is a real life example. I was working for a bank in Germany, and the project kickoff was in 2014. Then there's a long design phase which is following up, where you start writing concepts, you look how the infrastructure should be built up, you talk with 30 different teams that are involved, like firewalls, file servers, and so on and so on. And somewhere maybe 1 year later you start with the implementation. So that's what I've seen in many different projects. And what happened basically is, when you start implementing, you also have a deadline until the project should be finished. So when you start implementing, mostly you know you won't make it to the milestone you have set, and you start struggling with the plan that you made the year before. And what happens? So many, you know, we won't make it, and project managers often tend to throw in more resources to get the problem and the infrastructure up and running. And the problem behind that is mostly you have a big team already in place with many different teams working on it, and they're telling you to fix the problem, but in the end it slows things even more down, and in the end you're in trouble to get the deadline and the complete infrastructure up and running. And I've seen a lot of projects from 2,000 to 50,000 Citrix user infrastructures. They took nearly 3 years to be up and running, and in the end, the plan that you had to make a new and better environment, it looked the same like before, because you start at the end to create things or workarounds that you haven't planned before. So some are working after 3 years. That is a typical project. I've seen a lot of different infrastructures. And there's, when I looked, what could basically describe the problem behind such big projects, there's Hofstadter's law that describes that if you have a complex problem you need to solve, that you are not able to estimate the time you need, even if you take into account that it will take longer. And what I've also seen a lot of those projects, so when you're the system architect and try to implement good processes to get a stable environment, you start with dreaming like this, so that QA in production will look at the end like I was planning it should be. Yeah, but in reality it looks like this, because it's crushed into pieces, not because the technical side is not in the position to deliver what it should deliver. It's because if you need to take milestones into account and the deadline, then project managers are likely to say that they even don't care about all the processes that you implemented over the last years. It should run somehow, because when you're an external consultant or something like that, then you might get a penalty that you need to pay for the customer you are implementing that. So if we look a little bit, okay, how old infrastructures, or how we did it in the past, what is the summary maybe about a little bit of that? So they tend to be complex and hard to maintain, because we're not able to get it in a stabilized and good fashion up and running. And the teams in the past that tended to create or maintain those infrastructures were not very user-centric. They were more like, I need to get my system up and running, and I don't care if there's someone else who needs to have an optimized way of doing things. Maybe a good example are the firewall guys that always say that they cannot implement maybe something like a security group. They need to have a firewall or something in between just to have their systems up and running. And about half a year ago, I had the possibility to start as an external contractor at a startup company. And it seemed that it's really a cool project, because the startup was implementing drone flights all over the world, over fields, crop fields for farmers. And these drones were taking pictures, or are taking pictures, of the fields, automatically updating them to the cloud, doing a pre-bucket, and then in the back end, the imaging analyzer service that start to analyze the pictures to see if there's if there are any pest diseases or rambling weeds on the fields. And then after analysis of these pictures, they give it back to an app that runs on a notebook or an iPad. And then the farmer is in the position to start his spraying machines that are also fully automatically run via GPS with 1 meter approximately what they can how do you call it? They spray poison or something like that. Thank you. Poison for the pest. Yes. And that basically changed everything that I've seen before, and opened my mind for another sort of view on infrastructure, because that was a very, very big young team with 60 developers and 2 infrastructure guys there. They had like kickers everywhere, Nerf cannons. I don't know if you know these Nerf cannons, so they were playing the whole day around and doing weird stuff. And they had a big office where they were all sitting together. And for someone like me who had 17 years done a complete different business, it was very hard to come into this sort of team and to understand how they are working, basically. Maybe some words about the infrastructure that was running there. So they have about 600 servers running all around the world in AWS. They implemented a Netflix stack, from which I had never heard before when I started there. There were about 80% Linux machines, 20% Windows, and they had things like Puppet in place, Bitbucket for code versioning, and the monthly cost of the complete infrastructure was about 250,000 euros. So now one might argue the cloud is expensive, yes, but if I look back from an infrastructure perspective, I've never seen anyone from big enterprise companies really knowing what his infrastructure is really costing. So there are things like Gartner benchmark prices that you can take into account, and where companies try to be somewhere in the place around the price, but I don't know even any customer who's really capable on a cent basis to tell how much his infrastructure is costing. So how's your experiences of that? Is there someone who can really tell how much it costs? Not really. Right. So the discussion about the cloud is really expensive is always a little bit hard because you have no data on which you can really start to discuss what it's all about. Another thing that was really hard for me especially, I'm a Windows guy for all my life, and I've worked with PowerShell on the command line, so I know how it's working. But if you have 80% of Linux servers in one environment, then it's really hard to get through, especially when you have to work with Tomcat instances, with microservices, with Docker instances. So it's a hard learning path, and when I look back at the enterprise customers, there was also always a Linux team, and there was always a Windows team, and nobody was talking to the other because they sucked. And
they do.
They do, yeah. And basically it was always, they are like from another planet, so nobody talked to each other. And the problem behind that is, I think, if I now look back with the information I have today, you need to look for the special use case and take the best system at the end that does the job. If you are maybe looking into configuration management and want to do Puppet, for instance, then you need to have a Puppet server is running on Linux, and therefore you have to take into account that you need to struggle with such systems too. And if you look at Microsoft, in the past it was not so command line agnostic and Linux focused maybe, but times are changing. So we need to take into account that these both worlds are coming a little bit together, and that we now have the possibility to really run the workloads on whatever system we want to get the best solution in the end for the infrastructure we try to implement. Another thing I had to learn really hard is that developers are totally different people. So they're not like us, they are really focused on their own problem, and it's hard to talk to people really if both sides even don't understand each other because we are talking different languages. And another big problem was working in a Scrum team. So who of you knows what Scrum is and is working with it? Okay, you know what it is, and who's working with Scrum teams? Oh, quite a lot, that's cool. So I will come to Scrum a little bit detail later, but the thing is, I thought when you come into a DevOps team and developers that are sitting right next to each other, that the communication part to implement something would be easier. But in the end, I realized that I had never before sit in so many meetings without any further I don't know how to say it, without sense in the end, or a conclusion at the end, like in that time. It was really weird for me. It might be that other projects are doing it different, but for me that was a very hard part. And a few weeks later, I figured slowly out how the infrastructure was run. I thought when I came there that they are really the infrastructure, the best thing I would ever seen in my life, but it in the end felt a little bit more like this. Because, and that is one thing, if you let developers do the infrastructure, they tend to do everything just to get it somehow up and running. And I've seen a lot of discussions in the social media if enterprise architects are still needed today. And I think if you look at the experience I made, that the combination of both maybe is something that should be the right way to implement new sorts of infrastructures. And on the way to EBC yesterday, I found a cool tweet of Phil that exactly tells the same thing, and I think that I'm not alone with my experience, that there might be some other people as well that have made this experience. Back?
Yeah. What I learned is that bleeding edge, yeah, it's more about bleeding than about edge.
Yeah, you're correct. So, how could we do better? That was the question I had. Just a second. How could we do better? And why should we even care? So, if I look at the customers I had in the past, and they're mostly enterprise customers, and we Germans are very skeptical about the cloud, or we were very skeptical for the past years. Yeah, sure. The thing is that in the last few months, a lot of customers are stopping all of the infrastructure projects like they did it in the past, and they are switching completely to a new form of implementing infrastructures. First in the cloud, secondly with Scrum and with DevOps methodologies to stop their infrastructure from being not so efficient like they maybe should. And there's one big customer in Germany that started last year migrating all of his workloads into the cloud, and 3 weeks ago he shut down his data center. So it's like 10 months just to make a complete migration, and in the past I think this would have taken maybe 3 or 4 years just to get it up and running. And I came to a few other conclusions when I thought about it. So if you look at the startup from enterprise perspective, then there are a lot of unstructured developers doing stuff that from a data center perspective are just unstructured and shouldn't be done because we need some sort of processes to get it up and running. And from the other side, enterprise IT sucks for startups because they are not in the position to deliver infrastructures in such a short time like developers might want to have it in place. So what could we do? First thing is we should transform somehow these methodologies that startups use in a controlled way, and in a way where the data center and the enterprise architects are able to create controlled systems and learn from each other. And if you are thinking about moving your infrastructure to the cloud, is there someone here who has this complete workload in the cloud today? You? Who's planning to do so? You are already, huh? Okay, not really much. Okay, I've seen a few customers just taking everything one-to-one from the local data center, putting it in the cloud, and just thinking about why is this running so shitty. And that's where all these new services that Microsoft Azure and AWS offer you. You have to first assess your complete infrastructure to look at the services that are available in the cloud. For instance, if we look at, I don't know, some task-based things, there's, for instance, AWS Lambda. It's a function that runs serverless, and you only pay for every run that it does. So you only pay for the process when it runs, and when it does not run, then you also don't pay for it. If you're a customer having running these sorts of processes in your on-premises data center, and you move them one-to-one to the cloud, then you pay for the instance, although you shouldn't or don't need to do so. So you should think really exactly and plan exactly what you put into the cloud and what not. Another thing I saw at the startup was they were using the web console to configure the environment. So who of you is using the web console to configure his cloud environment? Okay. So the next thing is, if you do so, you're not leveraging the full power that it gives to you. You should use some sort of other mechanism to do it. and we should see infrastructure operations, that what we did in the past, exactly like we do it in software development. We need to have some sort of code that is reproducible with software tests to be able to prevent all those failures we did in the past. So how could that look like? Infrastructure as a code is the thing that comes here into place, and it enables us to create scripts to fully install complete environments. And it doesn't matter if it is in the cloud or if it is on premises as well, because it's all about the cloud, this presentation, but there are some software components out there that you can use even on premises and not only in the cloud. This, for instance, is an example of a CloudFormation script from AWS. It's downloaded for a complete Citrix environment. It was created once. You can download it even from Citrix. And this enables us to run that script 1, 2, 3, 4 times. It doesn't matter how often we want to create a new environment and how many of development, acceptance and production environments we want to create. And it enables us really to use it as many times as we want. Another thing we need to leverage if we want to start with infrastructure as code is that we start to version everything that we do in our infrastructure. So at the startup, I couldn't see any change management on the servers and instances that were made. Just people logged into machines, made a change in a configuration file, and nobody knew what was done. This can be prevented if we start versioning everything. So if we look at infrastructure as a code, then we have a script that is run, and by leveraging, for instance, Git. So here's a link for those who don't know Git. Now we can leverage Git just to implement change management, to get comments on why someone changed something. We can create different branches for different development stages, and it's totally free. So why shouldn't we use it? And another thing that comes, that is always talked about when we talk about infrastructure as a code, are these continuous integration, delivery, deployment, and testing mechanisms. And now we can play a little bit bullshit bingo with it about it, but it's really necessary to understand that only the complete usage of these components or mechanisms enables us to leverage also all the possibilities we have from infrastructure as a code and from the versioning of code. If you now talk about a little bit how we worked in the past, so there were different teams, maybe networking teams, software deployment teams, and so on. This isn't working in that combination anymore. So we need to leverage DevOps mechanisms. And DevOps is not about the tools we use, it's about the way we work together. And therefore it's necessary to put all the teams together, or maybe one from all the teams, to enhance communication between us. Because if you start putting everything in code, then not only software installations need to run in code, then also the creation of firewall rules, of IP addresses, and whatever it takes to get an infrastructure up and running. Everything needs to be integrated in that code just to be able to get this infrastructure up and running. And if you look at the possibilities we have today and the tools that are available, there's a cool cloud-native landscape here. It's not very easy to really put all the pieces together to get such an infrastructure up and running. So we need to very deeply understand what tools are in place to create, for instance, an AWS account or an Amazon account, to create an instance, to configure the operating system in the instance, to get the configurations on that machines, and so on and so on. Therefore, we need to have a deep look at the possibilities and the tools out there to be able to get a good combination of those tools. And one thing that we didn't do in the past in big infrastructure environments, maybe we were using the System Center suite, and that is something that is limited to the functionality that Microsoft delivers us. If you look at all the tools from this picture here, mostly of them are open source. So there's an enterprise edition where you get support, but there are also free editions. And the good thing about it, that we can reuse everything that the community is doing, and we can adjust the functionality of those open source tools. So we are not limited anymore to one of the manufacturers of software. We can leverage everything if we learn how to code. And there are a lot of those manufacturers out there that have their own verified libraries. So you can go to the website, for instance, here from Terraform, and you can look into the library of verified modules, because it doesn't make sense if you start every time from scratch. Just get all the information you need from the internet. Most of the things are also available in Git, so you can, even with the script, leverage and use the latest available modules during the deployment. There are a lot of possibilities we have here. And just to be able to do all of that, there's one console that sucked a little bit in the beginning when it was released. But even today, I see Linux guys using Visual Studio Code to create Docker containers and to work with all the scripts that need to be up and running. There are a lot of snap-ins for Visual Studio Code that you can integrate just to leverage infrastructure as a code and to use all those things from one PC, for instance. Now, how could just such a workflow look like? Getting infrastructures totally automated up and running. That's an example workflow. Start from left to right, so there comes a change into our environment, maybe to create a new complete account in Azure or AWS, completely up and running. Then there's GitLab, for instance, that you can use for the configuration management. That is the place where your code lives, where it is committed. Then there's JFrog Artifactory. That's a web service where you can put packages into it, like ISO files or Excel or whatever. It's bigger and not related to being code. And then there's an agent here, for instance, Jenkins, that is for the workflow orchestration. So here you create workflows. What happens if someone uploads a file, for instance, or changes the code? And Jenkins can directly start a workflow where from GitLab, Vagrant is started. Vagrant is, you can use Fusion or whatever hypervisor you want to get machines up and running, but Vagrant is a tool that creates automatically a development environment. It's capable of getting a new operating system from the internet, putting then on top with a Packer configuration of your operating system into it, and then uploading it, for instance, back to the sources where your AWS account, for instance, is then capable to create new VM instances from these machines. So it's a workflow that can be run maybe once a month to implement all the Windows updates, for instance. That's the simplest workflow you could imagine. And from there, then Terraform can be triggered. Terraform is a tool that is capable of creating environments not only in AWS, it's also capable to create environments in Azure or Google Cloud. And many big customers are starting to create their environments not only in one cloud platform, but also in more than one, just to be able for disaster recovery. And if Terraform starts to create a new account, then automatically these VMs are created that were created here before in the workflow, and the machines have a Puppet agent, for instance, for configuration management installed, pre-installed, and then this complete configuration that is stored in GitLab in the code is deployed automatically. So. Maybe just a few words about Terraform. If you look today, if you want to create a complete new infrastructure with a system center, for instance, then we need a database server, we need a site server, we need a lot of infrastructure components just to be able to push one operating system somewhere. Terraform is an Excel file that is 50 megabytes in size. I can put it on my laptop, and from there I can start creating infrastructures wherever I want, just for the simplicity of the tools we have here. And if we have created our configurations, then we are able to create some things like blue-green deployments. If you think about how we deployed updates in the past to infrastructures, how much headaches you have when you start deploying those things, maybe also on the weekends. With the cloud, we can just create a new instance next to the one that is running, have maybe a load balancer and something in front of that. If you are done with the deployment, we switch to the other environment, look if it's everything, if everything is fine and running, and then we can destroy the old infrastructure, and with the next update we do it the same way. So very cool way of deploying infrastructures without the need to work on the weekend or whenever, and to sleep well, because nobody wants to work on the weekend. So maybe a little bit about how to implement changes. In the past we did these big environments with a waterfall model, and today we are able to use Scrum to create changes and to implement things. What is the cool thing about Scrum? It's not something that takes years to plan something. Scrum is mostly deployed via sprints. A sprint is from 1 week to 4 weeks long, and for every sprint there is a sprint planning where the complete team discusses what is integrated in the next sprint. So if we create software, then it's very easy to deliver features that may be a customer request for the next version, because we can take small items from the plannings or from the backlog items we need to create, and we are very fast in implementing new features, and that's something we can also do with our infrastructure. So if something has a higher priority than something else, maybe a storefront update or whatever, I don't know. It's just like what would be the best example for that. But Scrum enables us to create faster, smaller, and better infrastructures or software in a shorter amount of time. And the next things, maybe, if you have implemented all of that and infrastructure as a code, then you can start thinking about such things like Docker or microservices to even more implement smaller pieces of infrastructures without maybe taking a complete instance of a PC, like I said before, with the Lambda services. And you can also implement such things like automated testing. I think in Prague, Jim was talking about Pester. Pester is a cool instrument to create automatic tests of our infrastructure components to see if certain aspects of our infrastructure are installed and implemented as wanted. And the hardest part on that is not the technical side, because I think all of you are some very smart guys and know how to implement new technologies and to read through the different features it has. The hardest part is the mind change in your head, because there are many people who are not capable working in a Scrum team, for instance, where they have 2-week sprints and need to implement at the end of these 2 sprints new environments, because some of the people also have some sort of feeling like they are controlled, because all the tasks are really directly put a name on, and you are the one who is responsible for the integration. So that is really the hardest part, and some people, you really have to look who you put in such a team to get the best result of leveraging such a new way of working. And if you implemented all of those things, then Netflix has a cool feature. They created an agent that is the chaos monkey that dynamically goes through your infrastructure and destroys instances. And then you can test if the infrastructure you implemented is rock solid and created like you planned it, or you will see, especially where you need to have a deeper look at, because that is also something we did not in the past. If someone made an error, you always try to not be the one who was responsible for the error. So that is also something you need to change in your mind. And there are 2 cool books I want to recommend you. It's one from DeMarco, it's Deadline. That is the old-fashioned way how we did infrastructure, and the Phoenix project that is a new way. It describes how Parts Unlimited, a big company that is creating parts for cars, transformed from the old world to the new world. So
it's a made-up story, though, isn't it? It's not true.
Yeah, it's not true.
Yeah, absolutely.
Yeah.
It's a good book, though. The Phoenix project is definitely a good read. Recommended from the back.
Okay, thank you.
Buy it, Namsen.
So thank you very much for your time, for listening to me, and I hope you have a great conference.